Lead code 886, possible bipartition. We want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people, and they should not go into the same group. Given the integer n in the array dislikes, where dislikes I is equal to, it's not like the person labeled b of I, return true. And they should not go into the same group. Is this like undirected? Interesting. First group is 1, 4, and the second group is 2, 3. Huh. Okay, but I think we can treat this as undirected, right? Because, okay, wait, what if construct n by n adjacency matrix, adjacency of u, v, undirected partition from u to v. If we can two-color this graph, then we're chilling. Oh, undirected denotes if to v denotes if uv dislike only traverse an edge if just uv. I mean, I guess that seems annoying, but we'll work with it. Then we're chilling, right? Okay, so boolean adjacency is equal to new boolean n by n, and because if we can two-color it, then it's bipartisan, right? Public void DFS. Three groups to divide. Oh, is it a fully connected thing too? That's a good question. Dislikes. Does our thing work? I mean, suppose we had like 3 groups. Okay, so these guys hate each other. Actually, let's say it's like 1, 2. So these guys don't like each other, and then there's like 3. But there's like 2 separate things. We will burn that bridge when we get there. To you in adjacency, and we're gonna color this int color. Right, we do need a color. It's 1 to n. I mean, I guess. Int color equal to int n plus 1. Okay. Okay. And we should probably pass in a color. Let's see. So we'll say color of u is equal to c, and for int v equal to 1, v is less than adjacency dot length plus v. If color of v is equal to 0, then DFS on v adjacency color, and let's just alternate using a negative sign. I don't know if that's efficient or not. Okay. Ooh, good question. If color v, this should be a boolean, yeah? Return true. Okay. and this is false. Return false. If color V is equal to C, return false, otherwise return true, and let's turn DFS on 1. We should probably build the thing for if adjacency U V and that for int D and dislikes. We'll say adjacency of D0 D1 is equal to true. Adjacency of D1 D0 equal to true. We can't put these people together. DFS1 adjacency color 1. We would want a semicolon. Is it? We want to split a group of n people. I don't know. We'll figure it out. I mean, I think by definition this thing is fully connected. Okay, well, shit. False. False. If color of V is equal to C, return false. Otherwise, return true. Is there a time where? Okay, what's happening here? Boolean res. Turn res. Arrays.toString color. Okay, so we have 1 dislikes 2, 1 dislikes 3, and 2 dislikes 4. So we start at 1. Which means when we constructed this, we have a... Oh, maybe we just don't even do that. We had 1 to 4. Okay. We had a 1 and then 4 connected. And then... And then 2 and 3 were connected. Okay, maybe instead res is equal to false. And we're gonna do for int I equal 1, I is less than n plus I. If color of I is equal to 0, res is equal to res over this. Right. Oh, actually, this should be true. Dun, dun, dun. Interesting. Okay, well, I'm confused now. How would we want to do this? So, we have 1, 4, and 3. We need at least 3 groups to divide this. Let's see an example of this. 1, 2, 1, 3, 2, 3. This is one big group. Right. Okay. Okay, how about this? If we start at 1, and we're going to 2, okay. Right, because it looks like this. That 2, we go to 4, and that's 1 2-color solution. I don't know. Right. 1. Color of V is equal to 0. But if color of V is equal to C, return false. You should be traversing a little more than that, but you stop at 1. But we're only going 1. Why? So we visit 1, we set, and then for int v. Oh, is it because? Okay, if u is equal to v, continue. Great. Okay, so we 1 2 4. Boolean cur is equal to dfs 1. System that out, then print out cur. Okay, and we're gonna. There we go. False. Because from 4. Why are you false? Oh. Wait. Yeah. So this. Okay, so we went to. This is what it looks like in our adjacency list. 2 dislikes 4. And we did 2-color it from this point, from 1 to 4. And then 3. Okay. So at what point did it return false? Here? Good old here. Interesting. This guy's adding me. I like this guy. Okay. So if color V is equal to C, we're at 4 for int. Oh shit. Oh, if we're trying to visit it, but we're not trying to visit it, are we? This is a good idea. I am game, as the kids will say in Honduras. Oh yeah, because we're just iterating through it, so we also want to make sure. If we're trying to visit, okay, so if this, right? If we can visit it, then it should be okay. So maybe let's stop doing this. Will this work? I feel like it shouldn't, because I didn't get to look. Yeah, okay. Pretty close, but I mean, with Boolean things, it tends to be that way. The Boolean problems, output problems, your what is it? They give you a lot of hope, but like there's only 2 correct answers, right? There's 4 outcomes. One of them's correct. Wait, no, there's 2 outcomes. There's, I guess, 4 ways. I guess you could be correct by mistake. I don't know. I'll think about it. Where is that printing from? Oh, here. Okay, so this outputted true when it was false. So we have 1, 2, 3 to 4, 4 to 5, and then 3 to 5. And what is happening here? We visited 1 5 times. What the? Why? Why? Okay. So this is obviously its own partition. Wait, no, sorry. So 1 and 2 have to be in separate, and then 3, 4, 5 have to be in a separate thing. Or I guess it would be more accurate to damn it. Look at it as this. So 3 could go here, and then 4 would go here, but then 5 also dislikes this, so I'd have to go here. Interesting, interesting, interesting. Yes, 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 yes. So what am I doing wrong here? I'm starting at 1, and we can 2 color this, so this is a partition. And but then 3, 4, 5. I go to 3 and 4. This should be false, right? I'm at 3. Wait. Let's use this test case. Why are you doing this to me? You visit 1 3 times. What are you talking about? Wait, is it because... Oh, god damn it. Hey, slow, but that's probably because we're printing. Okay, we're still really slow. I mean, I guess it passed. There's probably a better way to go about this for sure, besides just trying to color. Or maybe it's because okay, wait. So we can do this. Oh, we also exit really late. That's probably door I adjacency color 1. So we run this. This should work, hopefully. Yeah, there's not really a point in checking everything if door. That's still really slow. Okay. This uses a breadth for search. Interesting. If this... Maybe it is 2001 by 2001. Huh. Print neighbor. Okay, it probably is just this representation of a adjacency list. I mean... Oh wait, because... I don't know why I did this way. I normally do adjacency lists this way. New array list n. And for d in that, adjacency of d0 dot add d1. And we're gonna do that again. Right. That way we can do for int v in adjacency u. We don't have to check this, or this, or this. Actually, that makes a lot of sense because we are traversing over the. Okay, well, go. Okay, chase. Integer. Alright, we have to fill it. Int I equals 0, 1, I is less than equal to n. This should be n plus 1. Plus I, see if I is equal to me. Okay. Now how much faster is this one? Whoa, damn. Okay, yeah, it you know what? I'm pretty proud of this. We love CSE 101M. How do I stop?